I want to start with a question. Who here has worked with someone they hated? Pretty much every single hand. This could be the person who microwaves fish in the office kitchen. This could be the guy who buys a social media company, destroys it, lays off half the people without paying severance. Whatever it is, we all work with people that we hate. I have so many stories from the past which I will not bring up on stage. Now, I want you to imagine this scenario. You're an engineering team, and you've been asked to create an API for someone that you hate. You've been asked to do it, you've got to do it. So you could do it, you know, you could do it well, or maybe you could be a little bit malicious, you know, malicious compliance time. Maybe you could do something terrible. So let's think about a scenario where you own a ticketing system. Yeah, nice, boring scenario. You've got a ticketing system, you know, you can track tickets, do the thing, and this person needs you to build an API so they can write code against your ticketing system. We have to build this API for people, for this person that we absolutely hate. Now, as I said, we could be nice, but we're going to be mean instead. Who here likes being mean to people they hate? Okay, few hands. I'm glad that most of you are nice people. There's only a few of us who are mean. But yes, we're going to build a terrible API. And so what I want to talk about today is kind of 7 steps you can take to build that terrible API for people that you hate. And everything I'm going to be covering, I have seen in the wild, and other people have seen these things too. So this is all based off actual things that people do. So, number 1, the best API documentation. What is it? What's the best API documentation? No, some people say none, okay. Nice people would have said maybe an Open API spec. Yeah? Would you agree, Open API spec? Yeah, who thinks Open API spec is a good documentation? Okay, a few hands. Well, no, but if you're building it for people you hate, the best API docs are screenshots embedded in an Excel spreadsheet. Yes, this still happens even today. I actually used to work for Microsoft, and even now when they send me statements from my time working in the UK, because bonuses are taxed over 5 years, they send me tax statements as PDFs attached to an Excel spreadsheet, and they email me the Excel spreadsheet. Yeah, but I've seen this. I have seen people send a spreadsheet with embedded photographs of API specs. I think someone mentioned Word documents earlier as to how they get API specs. This kind of stuff happens. This is the best way to do it. And what's the even better way to do it is make sure they're wrong. But that's what happens when you do things like embed it in a photograph on a spreadsheet, is it gets out of date very, very quickly. So literally as soon as the business analyst emails this to the other team, it's going to be wrong. Now, if I was nice, Jim, I would do an Open API spec, wouldn't I? Who here has not heard of Open API? Okay, we all know what Open API specs are. They're industry standard. I can use my Open API spec to generate my client SDK. I can use it to generate API documentation. So a nice person would do an Open API spec. Next thing, get all the things. This is how we build our API. We get all the things. So if I wanted to create a new user in my ticketing system, what type of API call would I make? A get, exactly. I would get a new user. That's how I would do it. And for those who don't know why get's there in capitals, the reason get's in capitals is because HTTP has these things called request methods, also known as verbs. Okay. There's about 10 of them. 5 are the ones we care about. Get, post, put, patch, and delete. Get means I want to get some data. So when you make a call to google.com, you are making an HTTP GET request for data, and Google is returning you the HTML for the web page. So GET is how you get data. Post, put, patch, and delete are basically CRUD, create, replace, update, and delete. Post means I want to create something, a brand new thing. Put means I want to update my thing. Patch means I want to update part of my thing, and delete, obviously, means I want to delete my thing. This is industry standard. Do we all do this? Okay, seen a few hands, okay? And if we hate someone, we don't do any of these. We just do a get. Because it still would work. I can make a get, pass the body of my method over, and it would still create what I want to create. Now, nice Jim wouldn't do this. Nice Jim would support request methods correctly. So nice Jim would post to create a user, but we don't do that. We get, because we don't like this person. Okay, step 3. Naming things is hard. Yeah? The 4 hardest things in computer science, what are they? Cache invalidation, naming things, and off by 1 errors. 1 to 2 would get that one. Yeah, naming things is hard. So let's not bother naming things properly. Let's just come up with any old name that we want. And we can just throw in as many endpoints as we like to help people. Add ticket to add a ticket. Update ticket to update it. All tickets, get all tickets. Ticket spelt wrong. We don't care, we'll just spell it wrong. And once it's in that photograph in the Excel spreadsheet, we can't change it anymore. So let's spell it wrong. We don't care, we hate this person. This happens a lot. People will do this. Now, Nice Jim wouldn't do this. Nice Jim would not have all tickets update tickets. Because Nice Jim would actually use those HTTP request methods that we talked about, meaning we could have one endpoint. We could have ticket, and we could make post, put, delete, get requests against that one endpoint. We could actually have a nice, sensible name spelt correctly, and then we can take advantage of the request methods and name it correctly. Okay. Number 4. We don't need path parameters or query parameters, do we? We can do it in request bodies. It's a nice thing about APIs. We can send whatever data we like in a request body. So we don't need to worry about things like paths. We don't need to worry about things like query parameters. We want to get a ticket? Oh, we just make a request to /ticket, spelled wrong. And then in the body, we can put ticket ID 1. And that's how we get it. Yeah? That makes sense, doesn't it? Makes sense to everyone. Same with if we want to update a ticket. We can make a request to /update ticket. We put the ticket ID in the body, and we put what we want to update in the body of the request. Now, does this feel good? So far, so good, yeah. What about if you want to search for a ticket? Let's do the same thing. We have our search tickets endpoint, and we pass the search criteria in the body. Yes. This feels industry standard to me. Yeah. Except it's not. So what would Nice Jim do? How would Nice Jim do this properly? Well, path parameters, these are what we use to indicate the resource that we're interested in. When we're making an API call, when we go to /ticket, if we want a particular ticket, you would put a path parameter in there to define what that ticket is. We would go /ticket/1. That gives me ticket number 1. /ticket/4 give me ticket number 4. That is a path parameter. That's the right way to do it. And that way, we can use our HTTP request methods, can't we? If I want to update ticket 4, I don't call update ticket pass ticket 4 in with my body. I would call /ticket/4 and then make my put request to that. That is industry standard. That is what we expect. And of course, if we want developers to be happy with the API, we want to follow standards. Who here has ever started a job and then found that the team they're on doesn't follow standards, and so you're completely confused? That's quite a few hands I'm seeing there. Yes, by having these standards, we make it easy for people to understand what we're doing. If I'm using a path parameter, anybody using my API will know I can go, yes, /ticket/4. I can make a post request to write there. I can make a delete request to delete that. But if we don't do that, it makes it very, very hard. Same with query parameters. If I want to search for something, it's literally inherent in the name of a query parameter. Question mark key equals value. That is what I'm searching for. Question mark status equal open. Endpoint /ticket, question mark status equal open. This is how I would search for different tickets. So that's how we use query parameters properly. But we don't want to do that. We want to pass this in the body because we hate this person. Okay. Step 5. This is one of my favorite ones. Now, has anybody ever used a client SDK and they've called an endpoint and it's thrown an exception because there's an error somewhere? Maybe they've passed the wrong data, yeah? Anyone done that, throw an exception? Yes. That's a bad thing, isn't it? We don't want exceptions. My code might crash. I don't want that. So if my code returns a 200 status code every time, my client SDK is not going to crash, is it? Bugs fixed. There we go. So every time, I'm going to return a 200. Every single time. And of course, if there is an error, I do need to tell you, so I can put it in the body. Status 404, message ticket not found. Yes, Did you know there are global international banks that do this? These people have billions of our money, and they do this. I'm not going to mention any names now, but maybe come and ask me later, and you'll be horrified. But yes, there's a lot of people do this. And this is great, because the 200 error means, yay, we're OK. Now, these status codes are supposed to mean something. Okay. So 100s mean, hold please. Yeah, something's coming. 200s, here we go. This is what you wanted. We're good. 300s, go away. Go somewhere else. This is your redirections. 400s, you mucked up. 500s, I mucked up. That's what this code means. They have meanings. And in each group of numbers, there are specific codes that mean specific things. 200, okay, we've all seen that. 400, bad request. You've sent me something that I can't deal with. You have tried to update a ticket with a field that doesn't exist, for example. 401, unauthorized. You have no permission on the system. 404, not found. We all know that one. 418, I'm a teapot. Yes, that's real. Look it up if you don't believe me. That actually exists. One of the very first webcams was to monitor a coffee pot. So they actually came up as an April Fool's gag. There is a 418, I'm a teapot. But these codes are supposed to mean something. But we don't care, do we? We don't care. We're always going to return a 200, because that way client code will not crash. Now, what would Nice Jim do? Nice Jim would actually return the appropriate status code and give more details in the error body. And then it's the responsibility of the client to handle these correctly. But we're not nice, as I keep saying. We're not nice. Okay, step 6, atomic updates. Nah, we don't need atomic updates. Now, this one is kind of worrying when you see this in a global banking system. So imagine this. We have two tables, user and user details. Okay. And someone tries to create a new user. So we get the request to create a new user. We read the fields we need for the user table, insert a record. We then read the fields we need for the user details table. A field is missing, so we can't create the record. So it fails, and we return an error from our API. Does that seem fairly good? Fairly standard? Yeah? Except, of course, when I try to create the user again, oh, you're missing this field. Let me fill in the field and send it again. Well, I've already got the user in my user table. So the retry is going to fail. And someone is going to have to create a break glass account and get a DBA at 3 o'clock in the morning to delete the record so you can try this again. Yes, this happens. So what we should do is we should do an atomic update. And the idea is every time I make an API call, I should be guaranteed that the state of my system will only change if the API call is successful. Okay? If it fails, and by fail I mean return 200 with a status code in the body, obviously. But if it fails, it should leave the system in identical state to when I started. Everything should be completely atomic. And also, we can talk about idempotency as well, how I should be able to make the same call multiple times with identical data and not have changed the system, things like that. But in a perfect world, all updates should be atomic. Every API call I make should leave the system in the same state as before if it fails. It should only update the system if it's successful. And then finally, step 7. We know better than those consistent data type folks, those Rust people with all their consistent data types and all that, and it's got to be the right type, and these strongly typed languages. We don't care about those. What we care about is what different teams need. For example, there might be a reporting team who want to report on tickets via a CSV file. So they want a set of comma-separated values. That's what they want back. So that when we get a list of tickets, we will return them comma-separated values. There's another, with the website team, they want to render a ticket. They need JSON. So, okay, for a ticket, we'll return JSON. And then we have a reporting team somewhere else. They want XML, because they've got some really old legacy Java system, and they want XML. So we'll have that endpoint return XML. Yeah, fairly normal. Different types of data depending on which endpoint you call. Again, global banking system does this. Very scary. And also, what about if we're dealing with, say, salaries, for example? Salary could be euros, could be dollars, could be pounds. So why don't we just do it as a string so we can put a currency sign in front of the number? That would work, wouldn't it? Yeah. We're going to do that. We're going to do that. But actually, we're not going to do that. If I was nice, Jim, I would not do that. So if I was nice, Jim, I would have consistency with my responses. I would return everything as JSON. And if there was a team that said, I want this in a different format, well, OK, I'd add a query parameter, maybe. Question mark, format equals XML. And that will return everything as XML when I use that query parameter, rather than just mix and match it. Same with the data types. I wouldn't return $100,000, 27,000 euros. I would return a number as a number, and I return a currency as a field using an ISO currency code. So I would have strong types in my data. I would define these in my open API spec and have these strong types. But no, we're not going to do that because we don't like the person we're building this for. So turn this on its head. Who here works with someone they like? I mean, I'm not just holding my hand up because my boss is over there. But I work with some people I like. But yes, a lot of us work with people we like. And so when we are creating code for people we like, we want to do a good job. We want to make their lives easier. So how should we do this? We should provide an open API spec. We should document the API with a standard specification that people use. We should use the correct request methods. Use them for what they are for. Purchase for updating, patches for updating certain fields, things like that. We should make sure we use those request methods properly. We should have good naming. Sensible names, not badly spelled. Make sure they're spelled right. Well named, and then use things like path parameters and query parameters with that good naming and with those request methods, so we have a nice, friendly API for us to use. We should return the proper status codes. We do not return 200 for everything. If you are a teapot, return 418. If you're not found, return 404. Use those proper status codes. We should always do atomic updates. Every time I call the API, if it fails, the system should never, ever change. Ever. I should better fail because of the wrong data. I call it with the right data. It should fix everything. And then I should use consistent data types. Always return JSON. If I need to return a different data type for a different user, I can do that via query parameter. If I'm thinking about data, the data should be strongly typed based off what it is. If it's a number, it should be a number. Things like that. So that is what we do if we don't hate our users. And with that, that's how to build an API for people you hate. I'm Jim Bennett, Principal Developer Advocate at liblab. Come and find me on the liblab booth. You can't miss us. You might see a llama wandering around. And I'm all over the internet, Jim Bob Bennett. If you have any questions for this session, please feel free to reach out, connect with me. I'm happy to answer questions, tell more stories about some terrible APIs, and dig more into that. And with that, thank you very much for your time.